to the world where diamonds grind and spin. Concrete cutting experts, let the show begin. From diamond blades to core bits, we got the gear. Tune in to DPU, your podcast is here.
Welcome to Diamond Products University Podcast. I'm Jimbo.
And I'm Jim, and today we have Tom Walsh. He is a 41-year veteran at Diamond Products. He has seen a lot of different cutting over the years.
Hi, Tom.
Hi, guys. How are you?
Groovy. How are you?
Good. Thanks for having me.
Well, thank you. So this is our maiden voyage on the podcast. So, Jim, why don't you tell the people more or less what it is we're doing on the podcast in general?
So over the different episodes, we'll go over all the different areas that we train our distributors and teach you about the concrete cutting industry.
So we're expecting more or less concrete cutters to be listening. So for the most part, we assume you guys pretty much know where we're starting from, right, Tom?
Absolutely.
Tom, why don't you just tell us a little bit about what it is you do here at Diamond Products and why you're our expert today?
Well, mainly because I've been with the company as long as I have, I've gotten into a lot of different things. A lot of it is product development, bond development, specification development. Also, I do a lot on the safety and training sides for our salesmen, especially our pro salesmen out in the field. And I do a lot of work with the grinding and grooving market. I assist them as well.
So with the diamond blade and a core bit, they don't really cut. How does that work?
Now, actually, the blade actually grinds because it's the way the diamond is shaped and the facets on the diamond, it's actually a grinding process. Now, when we make a diamond blade, it has teeth, and those teeth are known as segments. Okay, the segments are a base powder metal that we cook at between 800 and 1,000 degrees to make that segment. But the key is the base metal powder has synthetic diamonds put into it to be able to make the diamond segment. And based on how many diamonds you put on it, the different types of metal powders you put into it determines how hard, how expensive, how well the diamond blades or diamond bit's going to work. Now, how is it made? That's a question I get a lot of times. Okay, and I kind of just said it. It's a base metal powder that we put synthetic diamonds into. Now, that's one step. But if we want to make that blade harder, we have to introduce some hard metals to the base powder.
And why would you want to make it harder?
To last longer. If there's the abrasion of the material you're cutting is key. So if you have something that's extremely abrasive, you're going to want something very hard to combat that abrasiveness.
Extremely abrasive, like what?
Like asphalt, cinder block, RCC concrete, rolled concrete,
okay.
Things that have heavy sand, heavy abrasion. On the other side of the coin, if you want to come something really hard and non-abrasive, you'll have to have a softer powder holding your diamonds in so that there's erosion, because there has to be erosion on the segment for it to work.
That makes sense.
The erosion is caused by the abrasion of the material. So we have to match that erosion level with the abrasion level of the material.
The erosion and the abrasion, and the abrasion and the erosion?
Exactly. And that's what it all boils down to. And then, like I say, we have different ways of making them harder, softer, whether with different metal powders or with more or less diamond.
So layman's terms essentially is we need the diamonds on the blade to wear off, and depending on the kind of thing it's cutting, we have to adjust the kind of metal that we use or the kind of...
That is correct.
Right,
because
to make it wear correctly.
Because if you have no abrasion, your diamond blade will not cut. If it's a piece of steel, now if the steel is embedded in concrete, that's one thing because you have the abrasiveness of the concrete surrounding it.
So that's helping it.
But if you're just cutting regular steel...
Or wood, let's say.
Wood's a little different,
right.
But same thing, no abrasion.
It wouldn't cut.
Yeah, so it just wouldn't cut because nothing's wearing that diamond, that metal away to expose new diamonds.
Because as Jim said, we're not cutting, we're grinding.
And you need the diamonds to fracture so they break off. And
exactly. And there's a cycle for the diamonds. They start off as whole, then they'll stay whole for a while, then they'll fracture, then they'll cut on those points, and eventually they'll pop out, and then you'll see the beginning of the new diamond starting to poke out of the surface there, and that's just a continuous process throughout the blade.
right.
Man, that's kind of cool.
Yeah.
So then what are you doing? Like you're going out on job, like you're going out to a job site today, right?
Right.
What is it you're doing? You're not going out there to tell them how abrasion works. You're
No,
just,
today I'm just going to look at a grinding head. They're having some erratic wear on a grinding head, one that they got from us, and they'd like me to look at it and try to determine what they can do to make it work.
all right, that makes sense.
So on a diamond blade, I mean, for the basics, what makes up a diamond blade?
Basically, you've got a diamond blade, you've got your steel core, whether it's 4-inch or 90-inch in diameter. So you have a steel core that has a place where you mount your segments, an arbor hole to be able to put it on the saw. And then the actual diamond blade itself is made up of metal powders, and of course it depends what type of metal powders based on the application, and diamond. And that's really it. And then it's put into a mold, and those metal powders and those diamonds are put into a mold. They're cooked under high pressure, high heat. That's what makes them able to work. It's almost like a diamond is created by pressure in the earth. Between heat and pressure creates a diamond. And you can see when we make these segments, we're doing the same thing. We're heat and pressure on those segments. That's what makes them so hard on a Rockwell scale, is that combination of heat and pressure.
Right on.
So the inventor of diamond blades was Richard Felker in World War II, I believe. I read that somewhere.
I think that's correct.
I believe you're correct. I'm not going to look. I just say yes.
And synthetic diamonds were made in 1950.
1, 2, 3 o'clock, 4 o'clock, rock.
That's the thing. We use synthetic diamonds, right?
We use synthetic
I'm not
diamonds.
sure. Everybody doesn't know that. I tell them I work because they're like, they think we have $1 million blades because we're using diamonds.
Every flag girl I've ever met asks me for a diamond. And I have to explain to them they're synthetic diamonds. And
Right.
people are like, you don't use natural diamonds?
Right.
No, they're not hard. Actually, they're not hard enough, and obviously they're extremely expensive. So,
Is that right? So the synthetic diamonds are harder than natural diamonds?
yes.
Oh, no kidding.
And they're more efficient because when you're making your diamonds and you're making them out of carbon, you can make those to whatever grade you would like.
Not just
versus,
willy-nilly from the earth
hardness,
for a
the
million
amount
years.
of facets on the diamond. There's different things you can do to fine-tune those to make them ideal cutting versus a natural diamond.
Right on.
So the lower quality diamonds have inclusions, and that's where it fractures.
That's exactly right. Yeah, if you look at some like the low-grade stuff that we see coming from overseas, a lot of the Asian rim countries, it really, truly looks like broken up glass in those bottles. Now, if you look at the segment and it's up on a wall in somebody's, store, you look at it and say, wow, that's got a lot of diamonds. That must be a really good blade.
It's got a lot of garbage.
Quality is key when you're docking diamonds.
Quality's choice, Jim.
Quality's
That's
choice.
what I saw.
You know, someone once said quality is choice.
Hell yeah.
Tensioning on a blade, what's that for?
Well, tensioning, when you're making a diamond blade, it goes through all kinds of different processes from the start to the finish. One of the main things that happen to it, it gets heated and reheated, cooled, reheated, cooled, reheated in the process of welding, in the process of painting, in the process of finishing. So that blade has to have a certain amount of strength to it to be able to put on a saw and spit it at a certain RPM, especially if you're talking high horsepower diesel saws. That blade has got to have the strength to run true at a high RPM. And typically, after we get doing all the machining to it, we have to reintroduce some strength to that blade to make sure that it will not wobble or flex when it's on the saw.
Back to the hardness of the diamonds. Frederick Mose, who's that guy?
He is the guy that came up with the first system for testing minerals and rocks to determine the hardness of them.
Mose?
Mose.
Mose?
Mose.
Like Dwight's cousin on The Office?
M-O-H-S.
like Curly and Mose.
Am I the only one that watched The Office? You guys know who
I
Mose
watched
is?
it, yeah, I watched
Mose is the best, dude.
But so it's a series. So basically, what you're doing is it's from 1 to 10, the Mohs scale. 1 being talc, 10 being diamond, and everything in between has numbers. And it's based off of a scratching method that you use to determine how hard that rock is. If you have a number 6 hardness rock and you take a number 7 scratcher and it scratches it, then it's a 6. If you take an 8 and scratch it, it's a 7. So it's
So
the
wait a
one-
minute. There's a Mose scale?
There's a Mohs scale that so I'll look at concrete when I go onto a job,
Like a Richter scale or...
more a hardness scale.
Right, but I mean, it's like that. It measures
Yes,
the...
it measures the
and
hardness.
it's named after good old Mose.
Named after Mohs.
Thank you, Mose.
And like I say, the first thing I do when I go on a job is I look at the aggregates in the concrete. I'll try to find a chunk on the side of the road. I'll grab my scratch kit and I'll scratch it just to know what I'm working with, and it'll not only does it give me an idea what I'm working with, but I think it gives the cutters a little more confidence that we're not just out there just to run blades. We have something that we're trying to accomplish, and we're going to look at all the different variables to make sure that they have the best blade.
Is that something anybody could do? Like is it a piece of equipment that you're using?
Yeah,
to do
and we
the
actually, I believe all of our salesmen have Mohs scratch kits, and
Okay.
and we have magnifying glasses for looking at sand, which is another important component of the material. There's one other test that we do, though. It's a LA Rattler test, and I do it on my own because we do a lot of concrete analysis, concrete testing for large projects. People send concrete to me for jobs where there's 1 million, feet of reseal or 2 million square yards of grinding, and I'll break that concrete down and give them an analysis of it. One of the tests I use is a form of an LA Rattler test, where you take a piece of rock or concrete, you put it in a cylinder with ball bearings, and then you shake it for 5 minutes. And after it comes out, you level you measure the deterioration of the rock that's in that cylinder, and it gets a number. Mohs, the higher the number, the harder the rock. LA Rattler, the higher the number, the softer the rock.
Oh, that's confusing as hell.
LA Rattler is still around and it's still used, but it's just a matter of ball bearing and a cylinder to measure the deterioration.
Just
after
beat the hell out of it, see how long it lasts.
Exactly.
Why do they call it L.A. Rattler?
LA Rattler.
Well,
Los Angeles is where it came
it
from.
came from. Okay.
Oh, they came up with it there, and it sounds like a
it was
rattlesnake
LA
when you
Rattler.
got the balls bouncing around in there.
Exactly.
So,
Oh,
so a
balls.
number 9 on the scale. What is
Number
it?
9?
Flint?
Flint would be probably closest to 9.
So couldn't you take pieces of flint in a segment and use it on real soft aggregate?
In a segment,
Yeah.
you kind of could. Whether it would be, it's probably not hard enough in the sense that it doesn't have metallic properties, so it'll crack and break in that situation. So it's
Dumb
more
question,
brittle.
but yeah.
But hey, it makes sense though.
So, we have an aggregate map in our catalog and on the website. It has color codes of different hardnesses.
A very good tool, especially for distributor salesmen and really anybody. There's all kinds of different aggregates in the United States. There's limestone, basalt, flint, river rock, granite, just all kinds of different aggregates throughout the country. And there's really not a lot of rhyme or reason to it. There's certain areas that you look at a state like Oklahoma that's, you look on a map and it's blue and it's limestone. Almost the whole state is limestone. But there are pockets in Oklahoma that have river rock. It would be almost impossible for that map to be completely aggregate.
Right.
But it's mostly just as a guideline.
That's got to be, we were talking about that before, that has to be somewhat unique to the United States because it's so big. Like, I bet if you're cutting in Germany, there's not as many different
Correct.
kinds of
Correct.
aggregates.
Canada has a lot, but then like you go to some place like Brazil, it's almost all basalt.
It's just
aggregate.
one
You
thing.
just never ever see anything but basalt.
We got it all.
We got it all.
USA.
USA.
So the color codes
We
on
rock.
the map, we have wet blades, thousands of different wet blade bonds. So we try to make it easier in the catalog and color coding the different bonds to the aggregate map.
Correct, and that's very helpful too. That map does. When you look at the usage charts in the catalog, you can see how the bond specification boxes are matched to the aggregate map. So it makes it almost foolproof to be able to pick out a bond, even if you're a new diamond blade salesman just getting into the market. This makes it real easy to know at least where to start.
That's cool, man.
Yeah, so that's on wet blades. So what's the difference between wet and dry blades?
Well, forever blades were wet because we silver soldered. Everything was silver soldered, so there was no such thing as a dry blade until like 35 years ago.
What's the benefit of having a dry blade now then?
Well, a dry blade, the advantage is you're going to be able to use it somewhere where you can't have water. Now, whether that's because of weather, because of freezing, and you don't,
Or indoors, maybe?
or indoors in a hospital, and this and that, where you can't have dust, safe rooms, things like that. Dry blades are good for areas where you have freezing weather, and dry blades are also good for smaller hand tools, chop saws, masonry
So
saws.
it's specific. It's a very
It's
specific thing.
and lower horsepower type stuff.
So is it that dry blades can be used wet as well, right? But
That
wet
is
blades
correct.
can't be run dry.
That is correct.
Okay, I heard that. I thought that's what it was.
And typically, if you run a blade wet versus dry, you're probably going to get 35 to 40% more life on a wet blade than a
So
dry
if
blade.
you can, you want to always use water.
You
But
always, whenever you can, you always want to use
if you're
water.
prohibited, you got the dry blade, you got the dust collection system from us. You can run it wherever you need it.
Correct.
Cool, man.
And on a dry blade, you can't just run it and keep running it. You have to kind of take it out of the cut and let it cool off. Right?
That is correct, because that metal, that's a good point. Yeah, the metal that the steel blank is made of in a dry application generates lots and lots of heat. So yeah, you can take short runs, but you always want to lift that thing out, let it cool off a little bit. And if you see that thing starting to flex or wobble, that means you need to pull it out of the cut because the blade's getting too hot. So it needs to cool.
That makes sense.
So out of all the different, I think we have over 9 basic quality grades on wet blades and dry blades. Which one do you use? How do you know which one to use and to sell?
Everyone is a different situation. If you're going to a guy that is in Texas, let's say, and it's a right to work state, right? And he's paying his guys $14, $15 an hour because there's no unions. Well, to him, the importance is life of the blade, because he's only paying $12, $14 labor. Now you go to New York where the guys are in union and they're making $40, $50 an hour. Speed is everything.
I feel the need for speed.
So
Right.
completely different needs just based on the area of the country. And but the one thing we have done over the years is we've made sure that we have something for every application, every grade we can use, every configuration we can use. We have tried to make sure that we have all the latest innovations available.
Well,
to
that's
our
where
customers.
60 years of experience in the industry comes in, because you learn that there's a lot of these weird one-offs, and we got you.
Exactly.
And I'm sure there's a new one every once in a while
Yeah,
too.
and we do. We'll bring them in just to
So
compete with-
essentially, there's cost of the life of the blade, the speed of the amount of time you're getting the work done, like you said, and then probably, then you got the quality of diamond too to take into consideration for your price of the blade, because the quality of diamond determines, like you said, either you're going to get longer time out of it or you're going to get faster time out of it.
Correct, and it really boils down to this. There's all kinds of formulations you can use, but we talk about everything measured in inch feet, which is length times depth. So if you've got 1,000 lineal feet times 10-inch depth, you've got 10,000 inch feet, right? So the way we measure a success of a blade, besides the speed, more sort toward the life, there are formulas for the speed as well, but you take the cost of the blade, let's say the blade is $1,000, and you've got 10,000 inch feet that you cut. You take the cost of the blade divided by the inch feet, your cost is 10 cents per inch foot. So
Right.
that's how we measure in our industry, especially amongst the professional
Well, that makes
cutters.
sense. And like you said, the nice thing is we have such a big and strong sales fleet here that you have that individual conversation with each situation to get them into the right blade. Like there's no exact formula. It's
Correct.
like, oh, well, you're in XYZ, so you get a 5.
Correct. And you do, like for distributors and that, we do have general purpose bonds.
Right.
And are they ideal for every application? No. Will they cut? Yes. Will they cut slower in some cases, faster in others? Yeah. But we do have a lot of general purpose blades as well, just for the general contractors and guys that really don't have that much equipment and they need one blade that's going to do a few different things.
Right.
Okay.
So on our website, we have a selling worksheet that gives you all the questions to ask to figure out what blade do you need, what are you cutting, what saw are you
I've
using.
seen that, and I think that's pretty detailed, and that's good for a distributor salesman especially.
Yeah, and that's on our website, so anybody can go on there and grab it.
What's our website, Jim?
DiamondProducts.com.
Ooh,
Sweet.
sounds so official.
Yeah, I know a lot about self-promotion, probably the most, but that is a shameless plug.
So all the different grades.
Don't
that
forget
we
your
have-
gear.
Yeah. Yes, we have Diamond Products gear.
DiamondProductsGear.com.
That's right.
We even sell bikinis.
Green concrete. So cutting green concrete. What is green concrete?
Green concrete is basically fresh concrete. Any concrete that's freshly poured. is laid down, and then there's a curing process that takes place once concrete is put down, where the moisture evaporates out of the slab, out of the concrete. It evaporates, and while it's evaporating, the concrete is curing. And what that does is it brings it up to strength. The longer it cures, the harder it gets, makes it more higher PSI, the harder it cures. Now, because the moisture is evaporating out of the slab is shrinking.
It shrinks?
Because it's losing volume. And because it's shrinking, it's going to crack because it has to. It has to crack somewhere based on the fact that it's shrinking. So now what we need to do is we just put down this big, expensive pad of concrete. So now what we do is we control the cracking that's going to take place.
Make it crack where you want.
Right, exactly. And we do that by weakening the plane of the concrete by cutting typically a third of the depth. If you've got 9-inch concrete, you're going to cut the control joint, usually 3-inch total depth, and then you're going to widen the top. That way, after you pour it, you wait until it's hard enough to be able to put a saw on it, and then you cut those control joints. And then wherever you cut those control joints, that's where the concrete's going to crack.
So you're kind of doing it after it's firm enough to ride a saw on, but not before it's so hard that it starts cracking.
That's
so there's
correct.
a little window in there.
There's definitely a window there, and there's been people that have lost that window.
I'm sure, and then it's too damn late, right?
But I will say, at one point, everything was done with either like 35 horsepower saws or 65 horsepower saws, which was tough because the concrete would have to get hard enough to be able to support the weight of that saw, which means you got to wait longer, which that window keeps shrinking the longer you wait.
Of course.
Then came the invention of the first cut saw. What that did was, if you picture cutting a piece of paneling and you don't want it to splinter, you put a piece of masking tape down first, and then you cut it so that it doesn't splinter. Then you lift the masking tape up. Very similar with the first cut saws. It's a plate that skids along the cut that keeps, just like the masking tape, keeps everything pressed down so there's no spalling, we call it, which is chipping.
The concrete version of splintering.
Exactly. Yeah, because if you go to cut concrete too early, it will spall, and it'll just the joint will look ugly. It won't be straight. It'll have all kinds of deformations.
Kind of reminds me of like cutting a piece of cake or something, or a piece of pie, and if it's not sharp enough, you're not getting a clean cut. You're getting a bunch of chunks sort of flipping off.
Exactly.
Right.
Or you try to cut something too early, and instead of cutting, you just smush it because it's not ready to be cut yet. And that's kind of the case here. But the first cut saw has a plate. So by doing the first cut saw, the amount of weight that is actually in the saws, they're pretty small. So your window is a lot larger. It used to be, of course, depending on temperature, depending on a lot of different factors, but let's say if you could cut 5 hours after the pour, with a soft cut, you could do it 2 hours after the pour. So it really, really gives you a much bigger window.
Is that firm enough at that time? Like just a few hours generally?
Yes,
No
yes,
kidding.
it is. Just because of the first cut saw, because it has a plate, doesn't need the weight that a big concrete saw
And I would think
has.
some of the time that the man outweighs those little saws. The man pushing it.
Oh, for sure. Yeah, usually is the case too. Yeah, for
Right.
sure.
So the cure time, it varies though between what you're doing to the concrete. It's like if you're a sealant guy, that's going to be a different cure
That is
time.
exactly correct. Yeah, like typically after you cut the control joints and then you widen them, Jim mentioned sealing, which you always seal the joints afterwards to keep the water out so the water doesn't get into the slab and create pockets and all kinds of issues. So we seal it.
So in our catalog, we have a line of saws and blades for cutting green concrete called First Cut. We have 2 saws, a small saw and a bigger saw, and then 2 lines of blades. All the industry colored blades, everybody knows, and you'll find all that in the catalog.
Yes, absolutely. And yeah, we've put together a very, very comprehensive first cut program that we have come very far, and we've been very successful in the last 3 or 4 years with the.
And as far as safety, safety is a big hot button topic. What is the latest on safety with our industry?
Well, I would say this. Obviously, safety-wise, there's big concerns over silicosis right now. That's something that you need to make sure you always have dust masks and things of that, because the silica that's in the slurry or in the dust of the material that you're cutting can get
no
into
good
your
breathing
lungs.
that stuff in,
no
man.
good breathing that stuff in. So you definitely want to make sure, especially when you're dry cutting. I've seen guys dry cut and they've got a big old cloud of dust around their heads, and I go look at them. No mask, no nothing, and it's just. And I will tell them, look, you need to get yourself a mask on.
Well, just in the 7 years I've been here, I've seen all of that change. Like, we've added so many vacuums that are specifically silica this and
slurry
for that,
pickup, dust
slurry,
pickup.
right.
Yeah, it's a contaminant. It's something that the government.
But that's something that
uses.
we've been aggressively addressing over the last 5 or 10 years.
That is correct.
Yeah.
And I'll say this, as far as safety, there's one thing when you're on a job, you always want to make sure you have your head on a swivel. You always want to make sure you look where you're going to take your next step, because when you're standing there watching equipment run on a road job, there's vehicles running up and down that slab all day long, and you may turn to walk out and you might walk right into a dump truck that's going by. So always keep your head on a swivel, know your surroundings before you even move. Make sure you know that it's a clear move.
Yeah, there's no autopilot on a
There's no
construction
autopilot.
site. Right.
There's been a few people that have been killed, diamond blade salesmen, over the years on job sites.
Right.
Yeah, so that's something we want to definitely pay attention to.
Then fall protection too. That's a big thing now.
Oh yeah, fall protection more and more, especially like we do a lot with the wall sawing. Core drilling takes you up to crazy heights. In this industry, our industry's built a lot on mistakes. So different things take us to different spots that really none of us ever anticipated being, whether it's on a bridge, whether it's on a dam, an Air Force base, or whatever. All those places have their own nuances as far as safety. So it's always good to make sure you have all your gear, and it's always good to make sure you know exactly what you're getting into when you go into a certain job, what some of the safety factors are, what some of the hazards are, things you have to watch out for. Because you could be in a plant, and the safety concerns could be a whole lot different than on a bridge.
So you mentioned a dam. The Hoover Dam was built in 1936.
I am your dam guide, Arnie. No one wander off the dam tour. And please take all the dam pictures you want. Now, are there any dam questions?
You know how many cubic yards of concrete that was?
What?
The Hoover Dam.
I know how many. Is this like a trivia question?
Yes.
How many was it? Do you know?
3.25 million cubic yards of concrete.
Holy mackerel, that's crazy.
And people think it's curing till the end of time, but they did a whole coolant system that was miles of steel pipe. It would have taken 100 years to cure, but it only took 2.
Because
It's
of
cured already?
Because of the cooling system.
Because of the cooling system in the system to be able to control the curing method, which is pretty sweet.
So
Hey, another did you know that in, I'm going to say it was like 1983, that Al Capone's safe was opened on live TV.
Yes, I did
around
know.
there,
I watched it.
And,
That was
and
horrible.
Roughneck out of Chicago, one of our big customers at the time, opened it.
Oh,
And
they were the
with-
ones that cut the...
They're the ones who opened it with the diamond saw blade, and that diamond saw blade was a W2033P.
That's fun.
Wow.
So the saw worked. It was just a worthless, empty vault.
Yeah,
that had
when,
nothing
when
but
they
dirt
opened
in
it, there was
right?
nothing in it.
Poor Geraldo.
Yes.
Poor Geraldo.
If only he was riding a camel, we'd have been fine.
So any crazy job stories?
Well, we've been a lot of different places. One time I was at a dam job, and a guy was cutting a trench, and the operator was supposed to make sure that at 2:00 he didn't open the dam like he does every day, because we were down there. Well, unfortunately, the dam opened while we were down there. Somebody else was on the controls. The area we were working with started filling up with water. We went up the ladder that was hanging down the side, and the concrete saw was underwater, ruined, never to be seen again.
Wow. Well, I think that's about really all we have today. I'm going to wrap it up. And
That's right.
Well,
Thank
thanks
you.
for having me, guys, on your first podcast.
Yeah, man. We
Hopefully,
appreciate it. It was fun.
hopefully we helped inform some of our viewers and listeners, a little more educated on diamond tools now.
in future episodes, we'll go over different categories and product lines and training. So stay tuned for the next episode.
Yep.
I'll be watching.
Cool. We'll talk to you then. Bye.
All right, see ya.
Diamond Products University reminds you to always read and follow all safety manuals and guidelines provided with your equipment. Proper cutting techniques and safety procedures are crucial for your protection and efficiency on the job. Always use the proper personal protective gear. The information provided in this podcast is for entertainment and educational purposes only and should not replace professional training or the advice of your equipment manufacturer. Stay safe and cut smart.